Welcome to today's lesson in Engineering Science Info. Today we'll be focusing on the topic of dynamics. We'll be looking at the April 2021 past exam paper. This is question number 4, and we'll be focusing on the first part of the question. This question deals with the horizontal plane under the section Newton's laws of motion. Let's take a look at the question. So the question reads, I have a bus. It has a mass of 5,500 kilograms. It travels at a speed of 75 kilometers per hour. Question number 1, calculate the kinetic energy of the bus. Question number 2, calculate the force required when the bus brakes and comes to a state of rest over 55 meters. So the first thing we're going to do is analyze our given information. If we look here, we are first given a mass of 5,500 kilograms. So the symbol which we use for mass is m, and that is equal to 5,500 kilograms. Next, we are given a speed. The symbol which we use for speed is v, of 72 kilometers per hour. However, here we will notice that speed should not be in kilometers per hour. It needs to be in meters per second. So to convert from kilometers per hour to meters per second, we are going to divide by 3.6. So 72 divided by 3.6, we now have a speed of 20.833 meters per second. So let's take a look at our first question, and the first question says calculate the kinetic energy of the bus. So we are first going to give a brief description of kinetic energy, and kinetic energy is energy that is gained due to motion. So simply here that means the object needs to be moving. It needs to have some form of initial or final velocity. The formula which we can use for kinetic energy is Ek is equal to half mv squared, and since we are only given one velocity, in this case it is moving at a constant velocity. Therefore, we are using Ek is equal to half mv squared. So when I substitute into my formula, right, we can now see that we have half. The mass here is 5,500. Remember, mass needs to be in kilograms. And this is where you need to be careful. The velocity that we need to substitute here needs to be in meters per second and not in kilometers per hour. According to our conversion, the velocity in meters per second is 20.833. When I put this into my calculator, I will now find that the kinetic energy of the bus when the velocity is 20.833 meters per second is going to be 1,193,538.195 joules. Question where it says calculate the force that is required when the bus brakes to come to a state of rest. Okay, it wants to come to a state of rest over 55 meters. So now we are given additional pieces of information in this question. Number 1, the bus is now moving a distance or a displacement of 55 meters. So the symbol which we use to represent distance or displacement is S. Number 2, we now find that the bus was initially moving at 72 kilometers per hour. Right, and we said we converted that from kilometers per hour to meters per second because the correct SI unit for velocity is meters per second. We did that by saying 72 divided by 3.6, and we got the velocity as 20.833 meters per second. However, now we find that as the bus was moving, the brakes of the bus was applied and the bus came to a state of rest, which means the bus stopped. So that means the bus now has two types of velocities. It has an initial velocity and a final velocity. So my initial velocity is going to be the 20.833 meters per second, the velocity that it was already traveling with. And the symbol which we can use to represent initial velocity is going to be u. After some time, we find that the bus came to a state of rest, which means it stopped. So when an object is at rest or stationary, that means that velocity is going to be 0. So the ending velocity of the bus is my final velocity. The symbol which we use to represent the final velocity is going to be v. So the final velocity here is going to be 0. So since there's only one force acting on the brakes of the bus, that force is going to be an applied force. The formula which we're going to use in this case to calculate the applied force is going to be F equals ma, and we use the formula according to Newton's second law of motion. So for this formula, there are two values that I need. The first value I need is the mass, and according to my given information, I now have the mass of 5,500 kilograms. I still require acceleration, and we do not have acceleration. So we need to check if the object is accelerating. So since I have an initial velocity and a final velocity, it now means the bus is accelerating. How do we know that? Because acceleration is the rate of change of velocity. That means the velocity has to change over a given amount of time, and we need two types of velocities, an initial and a final. According to this question, we do have two types of velocities. So we now need to calculate the acceleration, and acceleration can only be calculated using an equation of motion. So the equation of motion we are going to simply use to find this acceleration is v squared minus u squared is equal to 2as. So you must take note that the initial and the final velocities in this question are squared. So in your calculator, you need to square them as well. Okay, so I'm going to input the initial and the final velocities. So my final velocity is 0 squared. My initial velocity is 20.833 squared is equal to 2 times a, and we substitute the distance or the displacement here as 55. So I need to make a the subject of the formula. So on this side, I would notice that I have the 2 and the 55 multiplied to a. I need to do the opposite of multiplication, which is division, in order to make a the subject of the formula. So now it's going to look like this. Acceleration is equal to 0 squared minus 20.833 squared divided by 2 times 55. So when you input this onto your calculator, acceleration is going to equal to minus 3.946 meters per second squared. So please take note, the SI unit for velocity is meters per second, while the SI unit for acceleration is meters per second squared. Here you would notice there's a negative answer, right? We know that if we had to accelerate a vehicle, the speed is going to increase. However, here we find that the acceleration has a minus answer. The reason why there's a minus answer is because the bus is coming to a stop. So instead of the velocity increasing, the velocity is decreasing. The car is coming to rest. So when the velocity decreases, the acceleration is not going to be positive. The acceleration is going to be negative. We now call this deceleration. Okay, now that I have my acceleration, it means I'm now able to calculate the force that allows the bus to brake. So when I substitute the mass, it's going to be 5,500, and the acceleration is now going to be minus 3.946. So I substituted with the negative sign. It shows me that the car is coming to a stop. And the force here for the bus to brake is going to be minus 21,703 newtons. So we can include the minus sign, which shows us a braking force. So we should remember that when an object is coming to a stop or rest, the acceleration should be a negative sign, the velocity is decreasing, and for a braking force, we should have a minus sign. It shows we are bringing the object to a rest. Thank you for watching today's lesson.